Good day, everyone. We are now down to our fourth and final type of conic section, which is the hyperbola. But before we are going to solve the properties of or equation of a hyperbola, let's have a glimpse of the application of hyperbola in real life. Properties of hyperbolas have been used in the design of certain telescopes, satellite system and navigation system, and the study of comets. So certain telescopes and also my satellite system, especially um, to locate the coordinates of a certain ship in the ocean. We are using the properties of a hyperbola for that. Okay, so what is a hyperbola? So most of the students have a misconception that a hyperbola are just is just a two parts of hyperbola of a parabola. I mean, so they think na ang hyperbola kani siya is a parabola and then also the down is a parabola, which is not true. In fact, the properties of a hyperbola is much similar to the ellipse than to the parabola. Specifically, sa iyahang equation. So, a hyperbola is formed by the intersection of a plane perpendicular to the bases of a double cone, just like this. So, a plane intersect at two cones. So, ang iyahang result is a hyperbola. So this is the definition of a hyperbola. A locus of all points in the plane, the difference of whose distances from the fixed points is a constant. Each of the two fixed points is called a focus of the hyperbola. Together, we refer them as foci. So just like in the ellipse, it is a set of all points, the same ang ilang definition, except for this word, different. In ellipse, that is the sum of whose different distances from the fixed points is a constant. So that's p point. I'm sorry. That's pf sub 1 plus pf sub 2 is equal to a. This is for the definition of ellipse. But here in the hyperbola, the point in a hyperbola, the first focus minus the point in the parabola to the second focus is equal to a. So their difference is ang sum sa ellipse, while here in the parabola this is subtraction. Okay? So it's the same. The two fixed points are called the focus or together as foci. Okay, so what is the center? Just like in the ellipse and in the circle, our hyperbola has its own center. Refers to the point in the middle of the hyperbola and represented by H and K. The foci, these are also C units away from the center. So from the center to the foci, so by the way, the foci, kung asa nag-open ang parabola, they always devour its focus or foci. So our hyperbola is opening here at the left. So naapod diri ang focus 1, and in this hyperbola, it is opening to the right. So ang focus number 2 is na diri sa right side. So from the focus to the center, that's C unit. From the focus to the center, that's C unit. The same as sa to ang ellipse. So again, the definition for the point on a hyperbola to focus 1 minus the point on a hyperbola to the point of focus 2 that's 2a, or absolute value of this. So pf sub 1 minus pf sub 2 is equal to the absolute value of 2a. Okay, the vertices. So, it's like the same concept sa atong parabola. Ang vertex is here, at the extreme point sa both branches of our hyperbola. So, from the center to the vertices, that's a unit. So, from center to vertex 1, that's a unit. And from center to vertex 2, that's a unit. Together, from vertex 1 to vertex 2, that's 2a. So the segment from vertex 1 to vertex 2, this segment is what we call the transverse axis. So its length is 2a. Next, each co-vertex is b unit away from the center. So the segment W1, W2 is called the conjugate axis. So its length is 2b. So from this center to co-vertex 1 and from the center to co-vertex 2, that's b. So together from co-vertex 1 to co-vertex 2, that's 2b. So you can see there is a rectangular box here, but it's not part of the graph actually. It is just natawag na itong auxiliary box tungod kay dili dyan na siya part. It's just for para mas mapadali ang ato ang pag-graph sa ato ang hyperbola. So these are the asymptotes. So the two lines passing through the center which serve as a guide in graphing the hyperbola, each branch of hyperbola gets closer and closer to the asymptotes. That's why we call it asymptotes. So in the direction towards which the branch extends. So the equations of the asymptotes can be determined by replacing one standard equation by 0. So the asymptotes can be drawn as the extended diagonals of the auxiliary rectangle determined by the transverse and conjugate axis. So here are the asymptotes of the hyperbola.